In today's class, we are discussing about system calls. The operating system provides some set of services to the user. Those services are actually provided by using system calls. These system calls are written in C and C++ and also in assembly language. So initially they are written in C, C++ and assembly language. This every application or every programming language will have its own API, application programming interface. Example C, C++, you have turbo C, turbo C++, other, and Java you have Eclipse and etc. So there is an application programming interface that is associated with each and every language. This particular API provides some set of functions. Suppose that X is a function. This particular function will invoke some particular system call in the operating system. This function, that means let us take a function called open a file. We'll have that particular file, open a file, okay, using some particular application programming function. This function have some set of parameters p1, p2, p3, p4. We have to send even parameters, and it expects some return values also. After executing this particular system call, the system will return some return values, whether a successful execution or not successful execution, that will return some particular value. So we will send an application through application programming interface, we send some particular function that have some, that including that particular function we are also sending the parameters inside the function. Then we will expect some return value once the function is executed in the operating system call. Okay, so these system calls, how this particular API functions will be taken by operating system, and which system call will be executed. Let's see that particular topic. First, how the system calls are executed. First, whenever you switch on your computer, the system at the boot time, the hardware starts at kernel mode. Hardware starts at kernel mode. Once the hardware starts at kernel mode, then the kernel program will load all the system programs and user installed programs into memory. That means once the user system programs and user programs are installed, then it will start executing user programs in user mode. So there is always, if you run a program, there is always a mode switch from either user mode, that is user mode to kernel mode, or kernel mode to user mode. Okay, so how we can switch it? Let's see. First, if you run any API, and if you try to access any resource, that is a file in your hard disk is a resource. If you want to open a file, you execute API will execute open function. Then API will call a system call. API will call a system call. But currently the user process which are executing in user mode. So user mode number equal to 1. There will be a mode bit that is associated, that is 1. Once this particular mode bit 1, you need to set it to mode bit 0. 0 is the mode bit for kernel. So you need to raise a trap or exception. A trap or exception. Once you raise the trap, then the operating system will understand that now we need to change the mode. So the mode will be changed to kernel mode, and the mode bit will be changed to 0, and it executes the corresponding system call. It executes the corresponding system calls. How this particular system call will be executed? By using a system call interface between user application and this particular system operating system. We use a system call interface. So this particular system call interface, there is a table that is maintained. In this particular table, there are, for each system call, we have several system calls for operating system. For each system calls, there is a number that is associated with it. So 1, 2, 3, 4. So there are set of numbers that is associated. Whenever the user application invokes this particular system call, then this particular system call, after changing the mode bit through system call interface, it will find which table entry or which table entry the corresponding system call has to be executed through this particular API. And this particular, suppose we are using open, this open related to file, so there is a number that is related to file open, so it will take that particular number and execute the corresponding system call. Once this system call has been executed and the file is opened successfully, then it will return an integer value or some particular integer value to the API, so that it represents that the file has been opened successfully. Then this particular modification, this particular thing has to happen. Then we need to again change from kernel mode to user mode. Okay, so if you want to change from kernel mode to user mode, so we need the mode bit will be changed. What is the mode bit that will be changed? 0 to 1. We need to again change the mode bit from 0 to 1. While after changing the mode bit and after returning the value, whether it successfully open the file or even if unsuccessfully open the file, there is a separate return value that will be transmitted, so that the user application knows that the system call, whatever the system call that we are executing, is successful or unsuccessful. Okay, so there are several system calls are there. The process related system calls, file management system calls, directory and file system manipulation system calls, and several other system calls are there. In our syllabus we have only these particular system calls. So here, for each process, okay, that is created by using fork system call, so it will create a child process. Okay, if we want to put a process in a wait mode, then you need to use wait of status, wait and status. Okay, so next, if you want to use a process to terminate the child process, you need to use wait PID. You need to use wait PID. Then if you want to run or run a process or replace a process core image, we'll discuss what is core image in unit 2. You need to use execute v. Okay, then terminate the process execution and return the status, you need to use exit status. If you want to get the uh, process id of any process, you need to use get PID. Okay, then if you want to use return the value of caller's process group id, okay, grp means group id, you need get process group id. Okay, or if you want to use debugging, you need to use ptrace, process tracing. Okay, so these are the system calls that are related to process. Then there are some system calls that are related to file management, that is, to create a file, we need to use create, and to open a file, to close a file, we will use open and close function calls. After opening, we need to read and write. Then if you want to move the file pointer through programming API, then we need to use lc. Okay, so all these are used for file management system calls. In the coming units we will use this particular system calls. Then there is something called directory management system calls. MK directory means it is a collection of files. Okay, so this particular mkdir will create a directory. In regular graphical user interface, directory means a folder, right? Directory means a folder. The folder consists, in the folder you will store either the subfolders or different files. Okay, then if you want to remove that particular folder, that is delete that particular folder, you need to use rmdir. Okay, then if you want to change the directory, you need to use change directory, that is one particular folder you wanted to change from x folder to y folder or a folder to b folder, you need to use chdir, and you need to change from directory to directory. Okay, so if you want to change the root directory, you need to use chroot. And if you want to add a new file system, you need to use mount. If you want to remove that particular file system, you need to use unmount. Okay, so these are the system calls that are used in our operating systems in the coming chapters. Okay.